Hello students, in the present video session we'll discuss about virtualization appliances. So first we'll take black box virtualization. A virtualization appliance is an intelligent processing platform that attaches to the storage or a storage network. So the virtualization appliance is nothing but an intelligent processing platform. So intelligent processing platform. So that platform is attached to the storage. Either the virtualization appliance is attached to the storage or the storage network. Either it may be attached to the storage or storage network. A virtualization appliance may be implemented on optimized hardware or as the software that runs on a standard Intel processor. So we can say that the virtualization appliance may be implemented on the hardware level or the software level. So virtualization appliance can automate a variety of heterogeneous operating systems, host platforms and storage targets from different vendors. So we can say that the virtualization appliance, it may accommodate variety of operating systems, or I can say that host platforms and the storage target. Appliance may support fiber channel, iSCSI or any kind of protocols for host access and fiber channel ISASI, SCSI, SATA or SAS for storage. So the second category is in-band virtualization. So in the case of in-band virtualization appliance combines control information and data transport over the same path. So we can say that in the case of in-band virtualization appliance which combines the control information as well as data transport or exchange of control information and data will be through the same path. In the case of in-band virtualization device resides directly between server and the storage. So out of band virtualization that can be attached to the storage or storage network, but in the case of in-band virtualization, the virtualization appliance will be placed between the server and the storage. An in-band virtualization appliance using fiber channel may require two separate fabrics for server and storage connectivity. So in the case of in-band virtualization, since the virtualization appliance resides between server and the storage, we need two fiber channels are required or two separate fabrics are required for server and storage connectivity. An in-band appliance is a target to the client servers and an initiator to the back-end storage device. So we can say that the in-band virtualization is a target to the client server. So that will be the in-band virtualization appliance will be the target to the client server and an initiator to the back-end. Because the in-band virtualization appliance will be located between server and the storage. So the potential performance bottlenecks for in-band virtualization may overcome with processing speed and cache memory. The in-band virtualization appliance itself will become a bottleneck for storage transactions, particularly as a traffic load from multiple servers increases. One significant advantage in the case of in-band virtualization is its ability to enforce physical separation between separate the physical connection between server and the storage, because that is located between server and the storage. Because the appliance is a intermediary between the initiator and the target, it prevents servers from independently and inadvertently discovering and attaching to SAN based storage assets as might occur in a conventional SAN. So whenever it is necessary, so we can detach the connection from the server as well as storage. So this is the diagram for out-of-band virtualization. So here we can consider the implementation method is out-of-band, also known as asymmetric virtualization device, are sometimes called as metadata servers. So it requires additional software in the host which knows the first request location of the actual data. So the major advantage is scalability and performance, but the drawback is hard to implement. So the second one is in-band virtualization. The implementation method is symmetric. Virtualization device actually set in the data path between the host and the storage, as I mentioned before. Host performs I/O to the virtualized device and never interact with the actual storage device. So there is no direct, what I can say that there is no direct interaction between host and the storage device. The major advantage is easy to implement, but bad scalability and bottleneck. So here we can have different path in order to transfer the data and control message. So as I mentioned before, in the case of out-of-band virtualization, which separates control information path from the data path. Control information path from the data path. An out-of-band appliance attaches to the storage network as a peer node. In an out-of-band virtualization solution, server accesses data directly through the SAN, and it may require host resident software or hardware to maintain virtualization block address mapping. Out-of-band virtualization typically requires no change to the SAN environment. There is no modifications with respect to the SAN architecture is required. So high availability for virtualization appliance. A single virtualization appliance represents a potential single point of failure. So if you are considering a single virtualization appliance, which may represent a potential single point failure or one point failure. High availability of virtualization appliance requires dual pathing through the SAN and redundant appliance for failover. So in order to maintain the high availability, so we need to have more paths rather than the single point, that is dual pathing through the SAN, as well as the appliance whatever we are considering, there should be redundant. That means redundant appliance for failover. In an active configuration, redundant appliance may perform load balancing as well as failover capabilities. Redundant appliance exchange status via an Ethernet or fiber channel heartbeat protocol. So this is the diagram shows providing high availability for in-band virtualization, which requires deployment of redundant fabric, switches, appliance and path. So here we can consider that this is a dual path, server fabric, redundant in-band appliance. So we are having two appliances here, and dual path storage fabric. So in order to maintain high availability, either we can go for dual path server fabric or redundant in-band appliance as well as dual path storage fabric. So the diagram shows high availability for out-of-band appliance can be implemented with redundant units and links to a dual-pathed SAN. So here we can observe that we are having redundant out-of-band appliance, and the redundant units and links to the dual path SAN can be considered so that we can maintain the high availability of the data. So next we'll take appliance for mass consumption. So we can make use of combination of iSCSI and virtualization technology. So we can have ISCSI plus virtualization concept in order to enable the low cost but sophisticated shared storage solution. Economical iSCSI virtualization appliance may be considered for direct attached storage to provide virtualized shared storage. Low-cost iSCSI virtualization appliance provide a migration path from small to large shared storage networking. So here we can observe that low-cost storage virtualization is available through the appliance that provides iSCSI host access and basic pooling capabilities.